By now, you've probably seen a dozen tutorials that use a rotary potentiometer to demonstrate how to read analog values on an Arduino. Boring! Well, today I will give you something more valuable. In this video, we will go deeper and you will learn to use the analog input command on the Arduino to measure useful things like speed, pressure, position, and temperature using a mathematical technique called interpolation. I will also show you how to display data onto an LCD screen so that you don't have to keep your Arduino tethered to your computer at all times. Welcome to Lesson 3 of the Ultimate Guide to Arduino Automation. For the first example, I have a linear potentiometer here. This is used to measure the position of industrial equipment. This particular device has a range of 150 millimeters. This device is simple to connect to the Arduino, but we need to do a little math in our sketch to get meaningful data. To connect to the Arduino, we simply connect pin 1 on the sensor to 5 volts on the Arduino, pin 2 to ground, and pin 3 we will connect to analog input 0. That's simple. So let's start a new sketch in the IDE. This one is going to be very simple. We're going to start with serial.begin, and we're going to set that to 9600 baud so that we can use our serial monitor. And then down here in the loop, we will do a serial.print line, and we will print the analog read of pin A0, and we will do that every half second, so we need a delay of 500 milliseconds. Our semicolon, we will upload this to the Arduino board, and let's start the serial monitor. All right, so you'll see we're starting to get some numbers here, and as I push the rod in, it goes up to about 1023. If I pull it all the way out, it gets down to about 12. So let's remember those numbers. We'll need those in just a sec. So here's the formula. Don't worry, it's not as bad as it looks. Y is simply the position of the rod. X will be the analog value that we're reading on the Arduino. And we need 2 points. We need our endpoint all the way out at the 0 millimeter. We're getting a reading of 12. And all the way in at the 150 millimeter reading, we're getting a value of 1023. So if we plug our numbers in, the equation simplifies quite a bit. Let me get my head out of the way. So we end up with Y, which is the position of the rod, is equal to the analog read value minus 12, which is the minimum analog read value we were getting, times 150 over 1011. Now let's take that and throw it back in our code. All right, now back here in the sketch, we'll turn off the serial monitor, and we are going to go up to the top here. And we're going to add a variable. We're going to add a float because we want some precision. We're going to use some decimal points. So we will call this variable position. And then we will go back to our loop here, and we will write that our position is equal to float, because we want to use decimal places, of analog read A0, and we need our equation here, minus 12, and we're going to use times here, 150 with a decimal point because it's float, divided by 1011 with a decimal point, and our semicolon, of course. And then we're going to do a serial.print, serial print without the ln, and we're going to put our position. And then with our serial print line command, we're going to change that to be a text. I'm going to put a space and millimeters. So that should look okay. Let's upload this. And we will restart our serial monitor. And now we're seeing values with millimeters here. So 97 millimeters, we go in all the way. 150 millimeters, we go all the way out. Get to 0 millimeters. So looks like it's working pretty good. For our next example, we're going to be using an analog temperature sensor. This is the LM34 temperature probe, which provides 10 millivolts per degree Fahrenheit, which ends up making our math pretty simple. So for our value here on top, we get a range of 500. Now that would be 5 volts, which is the maximum our Arduino can see, divided by 10 millivolts gives us the number 500. And of course, on bottom, we have the full range of the analog input, which is 0 to 23 for the Arduino Uno, which makes our equation pretty simple. So let's go ahead and plug that into our code. But before I do, let me show you how to connect this to the Arduino. It is pretty simple. The left side of the face of the sensor goes to 5 volt, the right side to ground, and the center pin to our analog input pin. All right, so let's update our sketch to now read temperature instead of position. So anywhere we see the word position, let's change it to temperature. And then our equation will change a little bit. We will get rid of this minus 12, change the top number to 500, the bottom number to 1023. And since we're now measuring temperature, we will change that to degrees Fahrenheit. Okay, let's upload this. And we will turn on our camera and start the serial monitor. And as you can see, we are reading about 62 degrees, so it's pretty cool down here in my basement. But let's get a little heat on this thing. 70, 80, 90, 130, 170, 190. Okay, so up to 200 degrees pretty quick. Looks like it's working great. Now at the beginning of the video, I promised I would teach you how to display your values on an LCD. This particular one has what we call a backpack on the back. You want to make sure you get one with the backpack installed. I'll leave a link to where I got this one in the description. Now the Rev 3 of the Arduino Uno has 2 additional pins that we are going to use to connect our LCD screen. SCL and SDA should be labeled if you have a Rev 3 Arduino. The easiest way to update our code will be to open one of the examples under Liquid Crystal I2C, Hello World. Let's get both of these up on the screen so that we can copy and paste. We want these first 3 lines from this example code, and we'll put those right at the beginning of our code. Inside the setup loop, we will need this LCD init command, and we're actually going to replace our serial begin command with that one. We also want to turn on the backlight, set the cursor, and print our first word inside the setup loop. So we'll copy those 3 over. And we're going to set our cursor to 0, 0, which would be the upper left hand side. And instead of saying hello world, we're going to say temperature equals. And then down here in the loop, we're also going to want to use this cursor and print command. We'll replace our serial print ones. So we're going to set the cursor to 0, 1 this time because we'll be on the next row. And then we will write our temperature value from the Arduino. And then let's duplicate this print line here. And we will put degrees. Oh, we need our quotation marks first. Degrees Fahrenheit. And one more thing we need to do, just because this is going to be overwriting, we don't want it to look sloppy. I'm going to copy these two commands here and print them right above. Instead of saying temperature, we're going to do quotation marks, and inside we're going to do 16 spaces. And that will clear that bottom line every time we write a new temperature. So let's see if we got everything right here. Let's click the verify button. Make sure we don't have any errors. Seeing none, we'll go and upload. It looks like we're in business. So we'll turn on the camera, and you can see now we're reading 63 degrees on our sensor. Let's give it a little bit of heat. And there it's going up. All right. So in this video, we learned how to interpret values from 0 to 5 volt analog input devices. But what if we wanted to measure voltages higher than 5 volts? Say a solar panel, for example. How would we do that? Well, tune in to lesson 4, where I will show you how to measure both high voltages and high currents using an Arduino.